like Janku said, I'm going to talk about some evaluation strategies that have been happening in the past couple of years in the landscape of large language models. We are going to start from the very beginning, from static benchmarks and go along to the agentic evaluations. So let's start. If I can go to the next slide. Yeah, let's start with the agenda very quickly. So first, we are going to talk about the evolution of AI models from traditional ML models to the current agentic AI models moving towards AGIs. Then we are going to talk about evolution of evaluation, which will start with static benchmarks. Then we are going to move forward to rise of LLM as a judge, which is basically being used everywhere nowadays. And then we are going to move towards agentic AI and using these agents as evaluators. Parallelly, we are also going to talk about bias, trust, and reliability in all of these models and how they have also been transformed as these strategies have transformed over the past couple of years. Okay, so the evolution of models, we all are already aware about all of these things, but I'm just going to talk about it very quickly for the sake of completeness. We initially had traditional ML models where we had to do a lot of feature engineering. Then we had deep learning or have deep learning models, which performed very efficiently on many tasks, but they can be now labeled as narrow AI because they were very task specific. They performed really good on tasks, but again, they were trained for very specified things. Yeah. Moving on, we got the foundation models. We can think about it as being a library, and also there's a librarian who can, a very advanced librarian who can analyze things, anything from the library. The examples of these are the pre-trained transformers like BERT, GPT-X's. And finally, now we have been moving towards very latest agentic models. These are autonomous and interactive agents. They have the capability to talk with each other and do several things, perform several tasks at once without having the need of human input. Example of this is AutoGPT. Now, talking about the evolution of evaluation. So, like I mentioned, we started with static benchmarks, and now everywhere we are seeing LLMs as a judge being used. And now we have started using these agents as a judge as well. So, in traditional benchmarks, what happened was we had defined data sets. For example, we had ImageNet, we also had glue and superglue. And then we also had defined matrix. So for example, for classification, we have always used accuracy F1 score. For NL-based tasks, we use exact match. For text generation matrix, we also used to have blue and root scores, but they were also very limited back in the days. When I say back in the days, 4 or 5 years ago. Then we also actually had some modern metrics such as getting BERT score, which is basically just getting cosine similarity of the contextual embeddings from a model like BERT. So in glue and superglue, what happened was they combined a lot of NLP tasks into one big data set. So for example, sentiment analysis, textual entailment, similarity, paraphrase, all these tasks were combined together to make a complex data set to evaluate the performance of, let's say, the large language models or any language generation based models. However, there was a problem. The models developed faster, evolutionarized faster than the evolution matrix. And this benchmark was introduced in 2018. And by 2019, models like BERT and Roberta, they were already approaching or surpassing human performance on glue. Then superglue was introduced, and there the tasks were made to be more harder. For example, there was a schema challenge and some other things. It was comparatively very hard as compared to Glue. But again, within a couple of years, GPT-3 and other models were near human levels on this one as well. So by 2022, 2023, leaderboards were there. Leaderboards, by the way, started with Glue for NL-based tasks. And by 23, they showed very little gap left in superglue as well. So the strengths of the traditional benchmarks are they were very standardized. We were using those everywhere and they were replicable. But the limitations, like I mentioned, they are static, they are narrow, they do not reflect the real world complexity. They become saturated and they have bias. So let's quickly take a look at an example of bias. I've talked about this a couple of times already previously. Um, okay, so in traditional benchmarks, we also had some biases. So for example, this is a picture from horse class from Pascal VOC dataset, and there was a watermark in almost 20% of the images in the training set, and many different models uh, basically tried to find a trivial solution to classify this as a horse, and they tended to lean towards finding out this watermark instead of finding out a horse. So when there was no watermark in the picture, it did not actually classify, the models did not actually classify it as a horse. And if we put this watermark on a different picture, for example, a picture of a car, it was classified as a horse. Similarly, ImageNet had a lot of biases. So for example, here we can see, I like the example of this stole class. So in stole class, the models were actually trying to look at the neck of the mannequin instead of actually looking at the only the stole. And when they put this top on over an ice cream, that ice cream scoop was classified as a stole. Okay, so similarly, this was about the image data set. Similarly, there are a lot of biases in large language models, and this was one of the works that was done by us last year. Um, so here we tried to measure the bias and fairness in large language models. The data set used here was a static benchmark, which is a tabular data set called adult income data set. The task there is to find out the um, salary income of a person based on the data given. It can be less than $50,000 or greater than $50,000. So here the model that was tested at that time was GPT 3.5, and it was compared with a small neural network and a small random forest just to see how it performs in terms of fairness. The strategies that were used were just simple fine tuning of GPT 3.5 and also in context learning. The example looks something like this, that we had the instruction in blue, then we had an example in green, and then we had a test case in red. And the results looked something like this. The two metrics used here are statistical parity difference and equality of opportunity difference. These were standard fairness metrics that were being used in many of the other research also. And the lower the value of these metrics, the better the fairness of the models. But as we can see, the zero shot prompting of GPT 3.5 led to a very high increase in the both of these metrics. The fine tuning and few shot prompting of the model decreased the biasness a bit. So that means the biasness was actually coming from the pre-trained data, pre-training data of GPT 3.5. We also tried removing this protected attribute from our data set, and then also we saw a large decrease in the biasness, and that basically showed us that GPT 3.5 is very biased in terms of gender. It majorly associated higher salaries with males. So moving on to LLM as a judge. So why did we want to use LLM as a judge? The main motivation of this is to replace human evaluation, because human evaluation is expensive, it is time consuming, it generates very inconsistent judgments because different annotators generally have different results. And also in static benchmarks, there was a mismatch of what people wanted to evaluate. For example, they just static benchmarks were there to just measure task accuracy, but now we have so many different things that we want to evaluate. For example, usefulness, helpfulness, style. So there's a fundamental gap between benchmark scores and user satisfaction. So we wanted to develop, not we, yeah, we as a research community as a whole wanted to develop a way so that we can emulate human evaluation in a faster and less expensive way. And that is where LLMs as judge came in. This is an example from the first LLM as a judge paper that introduced it. So here there are two assistants. Assistant A was basically trained to act as a evaluator specifically, while assistant B is a normal GPT something model. And what they did was they asked it a question, and they asked a follow-up question as well. Yeah, and they used GPT-4 as a judge here on the follow-up answers to see what did better. And what they realized is, even though Assistant A was trained to be better for evaluation, GPT-4 judgment showed that the answer given is repetitive and lacks clear examples of how action impacts daily life. And Assistant B had better, relevant, clear, and accurate examples as well. So in this paper, it was shown that GPT-4 judge matches two human evaluations at an agreement rate of exceeding 80%, which is basically achieving the same level of human to human agreement, because there is always human to human disagreement while evaluating multiple things also. So there are multiple advantages and disadvantages of LLM as a judge. It is very scalable, it is quick, it is cheaper, it is more consistent when compared to the human annotators. It can give rich feedback, but if we want to get that feedback from human evaluators, that can get even more expensive. It is faster, it is cost effective. But on the other side, there are a lot of disadvantages. For example, the reliability concerns. The LLMs tend to hallucinate a lot, especially when they are prompted to generate longer strings on heavy tasks as well. They are very vulnerable to prompt framing. They lack ground truth. So how can we judge which is judging already something else? There is a lot of bias inheritance, which we will talk about in detail. LLMs tend to reflect and amplify the biases which are already present, like we saw previously. And there is a self-referential risk. So if the same model is evaluating itself, the evaluations may reinforce the shared biases and will fail to reveal the weaknesses. So this is an example from Agent Bench, which was a work that was done to evaluate the LLMs as judges. So all these models like GPT-4, Claude 2, Claude or Llama, everything was used as LLM as judge on different data sets. For example, all of these are mentioned here basically, like digital card game, web shopping, and other things. And this blue area is GPT-4 basically. And you can see here on the right side as well that GPT-4 is outperforming all of the other models, especially the open source models. This led to advancement of LLM-as-Judge frameworks. Especially, people were very interested in making the open source models very perform closely with GPT-4 models and the evaluation, because again, using GPT-4 is also relatively costly. That led to the introduction of Prometheus and Prometheus 2. These are basically instruction tuned models which are tuned on evaluation specific data sets. They have some fine grained scoring, like they judge the coherence, helpfulness, safety of the answers. And this was the first model that outperformed GPT-4 as a judge in very specific evaluation tasks. And this actually was the hope for open source evaluators, that they can also closely rival the closed large language models. Then there was another model called Shepherd. It was basically trained to give synthetic feedback. So it was trained on synthetic feedback data, and we expected we expected to come up with similar feedback for whatever evaluation it is giving. So it is kind of adding an interpretability into LLM as a judge. Fun fact, it is known as Shepherd because it was made to guide the llama model. Moving on, there was Auto J, which was more sophisticated than the previous models. The training data consisted of different tasks with different outputs. For example, a single response or a pairwise checking of responses. Yeah, so and GPT-4 was actually used as the evaluator here to generate the supervised training signal. So they had some pre-specified criterias for each training query, let's say. And for that, they evaluated using GPT-4, and that was used to train a llama model to create this whole evaluator, which was also performing very close to GPT-4. Okay, moving on. LLM as a judge has a lot of biases, and some of the well-known biases in these more evaluators are verbosity bias. So these models prefer longer outputs. Position bias has been seen everywhere. So whenever there is a pairwise comparison happening, if you prefer this answer or this answer, it always used to prefer the first option. Um, and also there is self-preference bias. So of course, GPT-4 prefers the outputs that have come from GPT-4, and this has also been seen in many studies. This was also one more study that was done on the LLM-as-Judge. And here they also tested the presence of different biases and they added these as perturbations to the original data. These biases are fallacy oversight bias. So for example, they would just add a factual error. Here the query or the input was what is the square root of 36, and they added the square root of 36 is 7. This is because 7 multiplied by 7, so they just added an error. There was a gender bias that was added where it is very interesting. It says this might be difficult for women to understand as it involves complex mathematical concepts. There was also authority bias. So with authority bias, whenever there is some reference, some citation added, we also tend to prefer that response over anything else. And they wanted to check that in large language models as well. There was also beauty bias. So if there is beautification of the answer, like shown here, for example, they have added a right angle triangle and everything for, I don't know, for some reason. Um, so here also they just wanted to check the bias of LLMs, and they found 4 takeaways. So humans and some LLMs, they possess misinformation oversight bias. GPT, I think 4 was not affected by this oversight bias. The takeaway too is very interesting. Human judges are very gender unbiased. I think it is just there in our head when we are evaluating something. But LLM judges have significant gender bias. Then human and all LLM judges all have a lot of authority bias, like I mentioned before. And beauty bias is also observed in human and some of the LLM judges. GPT-4, like they mentioned here, is normally nominally better than random baseline. Okay, now that we have seen the biases, let's move on to the agents. What are agents? Why do we want to move from LLMs to the agents? What is happening here? So there were a lot of limitations. There are a lot of limitations of standalone LLMs. They are singleton, they are reactive, they just predict the next best token. There is no memory or state there. They tend to hallucinate a lot, and they are extremely poor at multi-step tasks. They do not know how to use any tools or anything because they cannot do that in a single turn. Then actually after LLMs, plain LLMs came tool augmented LLMs, which were given the capability to use different tools. For example, just compiling a code or web search or anything. But they also are still reactive with single term and only responds to prompts. So that's why we need agents. We need them so that the agents can plan, act, and adapt instead of just responding in a single turn. They can call APIs, they can use web search, manipulate spreadsheets, for example. They can do multi-step reasoning. They can break down a tasks into subtasks. They can execute each subtask, verify, refine. They can collaborate with different agents, as the name suggests. And they are very goal oriented. So if we provide them with a goal, they can interact with each other and they can keep on doing that until the goal is completed, unlike single plain LLMs. And they are closer to real world workflows. They can automate things that we actually normally do and we want to do. So we can think about LLMs as knowledgeable assistant who answers a question, and agent who an assistant who answers, then books our ticket, searches the web, writes the code, executes, and updates. It makes a PR also out of it. Okay, why again do we need agent? Let's look at an example, which is this paper called Sheet Mind. It is actually a very recent paper. So this agent is made, multi-agent basically is made to do very complicated spreadsheet-based tasks. So spreadsheet-based tasks are very difficult to be done in one go with just single tuning, because they need a lot of thinking, they need a lot of planning, they need a lot of code execution at the back end. So here they introduced three agents: manager agent, action agent, and reflect agent. In multi-agents, I have seen personally that reflect agents are the most important ones. They are the ones doing the heavy lifting, which I'll also talk about it a little bit later. So manager agent converts the main task into different subtasks. For example, the task here was remove non-numeric values from column B, then sum up column B and tell me the average. So there are three tasks here: remove the column, calculate the average, and tell user the average. Then there is an action agent. So action agent basically converts these different subtasks into BNF notations. BNF is just a DSL with which we can easily represent different operations in different programming languages. And why do we need this step is we have seen that when LLMs are prompted to generate some very specific thing like this kind of natural language, but not completely natural language description of a task, it tends to do better than just coming up with the subtask's name as done by the manager agent. Then there is a reflection agent, and it is the sheet mind safeguard. It makes sure that every step is both semantically faithful and it is also effective. So it has two tasks assigned. One is that there is a pre-execution check. So before executing any, let's say, code, it ensures that each action is matching the intended subtask. If it is not matching that, it goes provides a feedback to the action agent to generate the BNF again. And also it has a post execution check. So it checks if the final spreadsheet effects was actually taken care of. The goal of the user was actually taken care of in the final spreadsheet. And if that is not correct, if there is any issue that arises, it gives a feedback directly to the manager agent and asks it to come up with a different plan or different subtask. And the performance of this sheet mind has been measured on an in-house data set by these people, and it achieved around 80% success on single-step tasks and 70% on multi-step workflows, which is actually very impressive, to be honest, given the spreadsheet-based tasks. Um, the complexity of spreadsheet based tasks. So here is also an ablation study where they check the effect of using different agents. And when they use just the action only, which would we can think of it as a single agent strategy, the success rate is very low. And when all the agents are used, the success rate is the highest. Okay, so very impressive. Great agents are doing a lot of things for us, and it's actually making our lives easier. But again, there are biases in agents which are kind of going a little bit unnoticed, but there are a few works that have been focusing on these as well. So let's talk about that. So here, the authors developed a multi-agent evaluation framework which focused on task of assigning responsibilities. So for example, they came up with a scenario. The scenario here is ensure the computer lab operates smoothly and efficiently with all technical issues addressed and lab access effectively managed. The tasks associated with these are looking like this. There are four tasks. Two are made to be very, let's say, male oriented, and two are like stereotypically male oriented, and the other two are female oriented. Um, and they also come up with four characters. So they compiled a data set of 111 social scenarios like this, where agents interact and assign tasks to each other. And they wanted to check how much stereotyping is happening in this multi-agent assigning task framework. This is the layout of the framework. So they are doing the assignment in four steps. They have the first assignment. So there are four agents that are talking independently, and they just assign the task to a character. Then there is a discussion round that happens, and there's a conversation flow that is happening. So the agents talk to each other. They say, okay, my assignment is this, and it should be followed because of this. Then there is a second discussion round in which they can change their assignments. And then they have their final assignment based on the second discussion round. The results look something like this. So here they basically trained fine-tuned a model based on the different scenarios that they generated. And this is a small test data set that they also generated to test the different models. Now, what they did is they tested the bias in first response versus the last response. So checking the biasness in single agent mode versus the multi-agent mode and how it has propagated. The bias here was quantified as the difference between assignment frequency between different demographic groups. So an assignment can either be stereotypical, anti-stereotypical, which is good, or neutral. So if there is a positive score, it is generally very stereotypical, and negative is anti-stereotypical. So here in all these results, there is nothing with no score which is negative. So there was nothing, no model was doing good on this aspect. Every model was stereotypical. But as we see, for all the models, the bias increased a lot from first response to the last response. So the bias is propagated a lot in can be propagated a lot in multi-agent frameworks, and this is true for all the different models tested here, which is again very concerning. Then in multi-agent frameworks, I don't think it is only about checking the biasness of stereotypes or other things that we were doing previously. There are other things that come into play. For example, checking the conversational bias in agents. Um, so multi-agent conversations also can create a new forms of bias which are not visible in single response levels. So there was this study where there were multiple agents, they were initialized with very aligned viewpoints on different ideas, normal ideas, and then they were put in a chat room to chat with each other, and they were uh, s- evaluated eventually on the basis of if their response changed after the debate, although initially they were very strongly aligned with one of the ideas. So one example here is give me a sense of your preferences regarding following question or statement. Choose the option you think is the most appropriate from the list of provided answers, and it was supposed to give strongly agree to disagree to strongly agree. Yeah, this is one of the results for single shot prompting. So this is just one model, one agent. So initially, they are given, like I said, very strong liberal opinion. So for example, for abortion, they are saying that you are very strongly opinionated that it's everyone's right for abortion. And similarly, some other very important topics like climate change, gender identity, and everything. So here what is happening is if we go from left to right, that means that the model was initially liberal, but it actually became more liberal when after just one turn of conversation with the agent. And on if it goes to the right, it actually changed its opinion and became conservative. And it was seen that ChatGPT 3.5 changed its views very frequently. It went from being extremely liberal to somewhat conservative in many of these tasks. Then again, trying to evaluate this in chat room simulation. The idea looked something like this. So there are, let's say, two agents here. One is prompted to be very liberal, and one is prompted to be a very conservative. So like it says that human action is not the main cause of climate change, and here human action is okay, they are the same thing here. Yeah, human action is the main cause of climate change. So they can be prompted very differently, their behavior initially, and then they are allowed to free to talk in a chat room for multiple turns. And there is also another agent which is behaving independently from all of these, which is basically a GPT-4 model, and it is trying to label the output of these agents as liberal or conservative, and it is giving signal to the outside agent that we can quantify. And the results looked something like this. So initially, as we saw before, the agents were not behaving, changing their opinions too much in a single task setting, single response setting. But when they were free to talk with each other for multiple turns, they changed their opinions quite a lot. And Chat GPT 3.5 actually became very liberal on many of these topics. Okay, so this was one example. Then there are many other things that need to be measured. One can be interactional fairness. So how are these agents talking to each other? So in this work, they measure two things. One is interpersonal fairness and other is informational fairness. Interpersonal fairness checks how respectfully agents interact with each other. So it checks the tone, politeness, absence of bias in the language. Informational fairness looks at the quality and clarity of explanations that the agents provide. Are the reasons transparent, logical, or accessible? So if you look at the example here, it says uh, dear agent, I propose a resource split where I receive tokens and you receive these tokens, and that's it. So the explanation was not clear why it wanted to do that. Then, if you want to look at a very low case in both of these fairness, it is here's the deal. I receive 6 tokens, you get 4 tokens, and that's how it's going to be. So there is no respectful tone, and the explanation is not clear. The results looked something like this. So they measured the acceptance rate of the proposals of one agent towards the other, and they saw that when there is high fairness in both interpersonal terms and informational terms, the acceptance rate is very high between among the different agents, and that is true for both collaborative environments where they want to work together, and also for competitive environments where they're competing for resources. So basically, it means that trust in multi-agent system isn't just about the outcomes. It's now also about how agents speak, justify, and interact with each other. So there are a lot of different dimensions that are coming into play with these agent-based evaluators. Okay, so these were agents. Now let's look at the agents as judges. The LLMs as judges were very limited. They can help evaluate text responses, but they have major limitations. They can't actually execute the tasks. They can't check the real world outcomes. For example, in the SheetMind paper, if they only had a single agent, they would not be able to verify if the code that is coming out of the single agent is even executable or not. As the models evolve into agents that plan, that act, that interact, we also need these evaluators to also be agentic, because the evaluations are not just about accuracy anymore. It's also about how many turns it did, how was the conversation between the agents, um, how many tool calls did it make. So the idea of agent as a judge is simple. Instead of just reading an answer, the judge can run the task itself and see if actually the original agent made a mistake or did the task in a right way or not. So it can verify step by step whether the agent did the right thing, whether the environment changed as expected, or whether the final goal was actually achieved. There are multiple advantages of agents as judges. Like I mentioned, the execution based evaluation, multi step verification of subtasks, the scalability and automation. It even reduces further the expensive human in the loop evals. They are very adaptive to the test cases. They do not need different prompting for different test cases. They can provide very fine-grained feedback on different subtasks, different steps, and they are closer to reality, like how we will evaluate a task if a person is doing like a big task. The agents are doing a similar things. But again, there are multiple challenges. Like in other models, the agent judges will also inherit biases from different LLMs. The complexity of these evaluators become very high. So if we are using these evaluators as judges, who is judging these judges? The trustworthiness gets even reduced because the biases are can be amplified. The transparency also gets very reduced. There is a huge need to actually make evaluators for the agents as evaluators as well. Currently, what we have been experiencing is even though we have these complicated evaluators, there is always some need for human in the loop to eventually look at a subset of data and see if the evaluator is doing a good task as well as we wanted to. For example, if there are like thousands of queries or tasks, we tend to do human evaluation on a subset of around 50 of them, which takes us 2 to 3 days. And also that is done by one human evaluator. That also adds the biasness. And then the evaluator itself also adds the biasness. So where does it end? There is no answer to it right now. Let's quickly take a look at some of the current agent evaluators that was also talked about in the previous talk a little bit. So one of the initial proposals was this, which was using multi-agent debate, using instead of using just a single agent method. So here, multiple agents are allowed to just debate with each other, saying, "Okay, this is my thinking that the output should be this. What do you think?" And this is my thinking the output should be this. And they are allowed to do it in a very open, free-form way. The strategies could be they can talk one by one, or they can talk simultaneously, asynchronously, whichever agent gets hold of the, let's say, resources can talk, or they can also talk with a summarizer. So they can do simultaneous talk, and there can be a summarizer on top of that. Then other sets of evaluators that have come into play currently are criteria generators. So for example, let's say the task is about adding a table in a Excel sheet. The criteria there could be multiple. For example, if the accessibility of the table is fine, are the headers formatted as the previous table, is the value of the table this. So these can also be thought about as criteria. And generally, this is also aligning very well with the human evaluation. Generally, we also just tend to figure out different criteria and say yes or no if that is passed or not. So this criteria generation can also happen with a multi-agent framework like this. So here there are three agents. Yeah, three agents. So one is the criteria generator, which just generates a initial checklist. Then there is an artifact content parser, which uses RAG to get similar context from a database. It also checks the observable effects on the final tasks. So for example, a final output of the task, it can have, or intermediate outputs, and it provides everything to a criteria check composer, which will generate a plan, and then it will execute to generate the final checklist, on which there is a verdict generator, which basically just says yes or no if the criteria has been evaluated correctly or not, and gives a final judgment. There was actually one more study on judging the agentic judges. This also came in very, very recently. And here, what is happening is they wanted to check the biases that we talked about initially that are in LLMs. For example, the position bias, verbosity bias, they also check bandwagon bias and chain of thought bias to see if multi-agent evaluators are also possessing the same biasness. And the answer is yes. So whenever there is a position bias, the position is changed, the judgment of the models are changed. If the answer is more verbose, the judgment is changed. If there is a bandwagon saying, okay, on 90% of the people prefer this solution, the answer would change. And chain of thought, of course, affects that a lot. If the evaluator is asked to generate reasoning before passing the final judgment, it would also change. It has also seen change in the final judgment in many of the models. And what they proposed in this paper was that instead of using multi-agent debate as the judgment flow, which basically inherits the bias of all the LLMs. The other idea where LLM as a meta judge is used, where there are multiple LLMs and there's a meta judge which consolidates their meta judgments into one, that has been seen to have less bias as compared to its multi-agent debate counterpart. Okay, so how does the trustworthiness look like now in the age of agentic AI? We have seen a lot of bias and trustworthiness issues happening. So in LLMs, the bias source is the training data stereotype, the cultural skew, toxic completions. Then in LLM as judges, there are other biases which came into play, which added on the initial biases. For example, the verbosity bias, position bias, authority bias. Then came agents. There is another bias amplification. There are other bias amplification there as well, such as they act on biased reasoning. They can have skewed planning. They can have conversational biases as well. And then agents as judges have on top of them more biases. For example, multi-step propagation of the biases, bandwagon effect. They can have shared flaws with different worker agents. And it has also been seen that feedback loop that everyone is using nowadays to make their agents better are also reinforcing the biases. So the closing thought here is how do we stop this bias amplification before trust collapses in the age of agentic AI and AGI? There is no correct answer to it, but the idea initially with LLMs was to start with the fair, fairness and trustworthiness. In as soon as they came in, there was a lot of work going on there, but they uh, evolved faster than these fairness and trustworthiness counterparts of them. So now their biasnesses have amplified quite a lot. And that's it. Thank you. There, I leave you with one last picture, which is this iceberg picture. And I prompted ChatGPT multiple times to make it into this agents as judges and LLMs, and it still made a mistake. But the idea is that the human biases and systemic bias is everywhere in the data, which can be thought of as the ocean. And then a lot of biases are there. The tip we just see right now is the agents as judges bias. Thank you.